Good morning to everyone. My project title is FPGA implementation of hardware function evaluators using ROM based approximation approaches. The main aim of this project is to minimize the time and reduce the area by which we can increase the specified hardware to be required. First, my abstract is the function evaluators are used here. For this, what is the aim to use this function evaluator is to prioritize speed over accuracy. Fast multiplication can be happen using several useful arithmetic operations. Data is stored in ROM using system performance. Memory addresses are segmented and remapping is done fast through fast multipliers. Then existing system of my project is LUT size can be reduced to approximate 90% of total area cost. Computation hardware becomes more complicated. It requires additional address encoding to index the LUT that stores the polynomial coefficients. The drawbacks of the existing system is it requires large area, delay overhead, increases table size for some elementary functions. Table reduce method has larger impact on cost when used in multifunction evaluators. Different tables can be used for different functions. It increases the area occupied. The proposed system is the memory segments can be divided into many segments and it can make the segmentation non-uniform. This segmentation improves accessing speed to be fast. Rearrange the memory addresses as per the requirements of the function, so the extra carry propagate adder can be eliminated, leading to smaller critical path delay. This is the screenshot of my project. This includes the logarithmic function, by which the logarithmic function can be used as inverse logarithmic functions. First is used is clock. The clock is given as initially 0, then reset can be given, by which I am using here three addresses, namely address 1, address 2, address 3, and output can be seen using signals. The count can be increased from initially 0 and then up to 9. So the output shown here is address 1 initially given as 1 and then it can be incremented up to 5, by which the addresses can be increased from 0 to 9. This is the another screenshot of that logarithmic function. We can see here that the output of that function can be given as 17, by which it can be given by functioning can be included by substituting the values of that logarithmic function. The count can be given up to 4. So the signal out can be given by one by one process of this logarithmic function. This is the analysis summary of my project, by which includes synthesis report of power analysis, which includes that power can be given is 69.31 millivolt. So we can reduce this power by using this logarithmic function, and the timing analysis given here is 11.345 nanoseconds, and the analysis summaries of this pins can be used is up to 22 pins. So application of my project is it can be used in 3D graphic system, digital signal processing, microprocessor, image processing and multimedia. These are the areas where the project can be used for implementing the functions. The modules used in my project is address remapping, function evaluation, FPGA implementation. The tools required for my project is Altera, which can be used for simulation, and Quatus2 used for synthesis report. This is another program which can be used for this. First is FPGA implementation. In this, what I am using is some polynomial function is used. The expression used here is 3x square plus 5x plus 8. For this function, what I am including is initially clock is 0 and reset is given as 1. The three addresses are used here for using this application, so the count can be increased from 0 to 9. Here I am using is 3 bits, namely, so the output maximum output what is given is here is 1869. The output can be given here, so it can be used to increase the speed and reduce the delay occupied in this. The polynomial function power analysis what is given is 70.25 millivolt, and the timing analysis is 11.809 nanosecond, and analysis summary of this synthesis is it requires registers of 3 and pins of 30 pins. The work methodology of my project is first initially segmenting the addresses using with and without remapping. The functions of some evaluations are taken and to be evaluated in address encoder. For evaluating a function at different places, many clocks are required. Instead of that, we can use single cycle for that function, which will reduce the time required. Hence, the number of cycles per instruction can be reduced. The advantage of my project is time can be reduced, accessing speed can be increased, and delay can be reduced. These are the literature survey of my project which can be included for evaluating this. Namely, high performance special function unit for programmable 3D graphics processor. What say this is, it can increase the speed by reducing the segmentation of the analysis of this paper. And then another paper is hierarchical segmentation schemes for function evaluations, which include it can be increased by speed and reduce the delay area required. Thank you.